Hi, and welcome to the Build Your Own Data Logger course, brought to you by Wildlabs and Freaklabs. I'm Jacinta from Freaklabs. This is Module 3, the Command Line submodule, Lab 3. In Lab 3, we're going to go deeper into understanding how to pass arguments from the serial console to dynamically set and control parameters in our application. So we're going to dynamically control the rate at which we blink our LED through the serial monitor or console. In Module 2, we learnt how to blink an LED. However, we hard-coded the pin number and the delay time. So when we wanted to change the delay time, we had to go into our application code, change it, compile, and re-download the code to the board. In this lab, we're going to avoid all of that by setting the pin number and the delay time as a parameter that we can change through the serial console. So, let's open up the Arduino IDE, connect our board, and get coding. Just as we did before, we're including the Command Arduino library at the head of the program, using the #include macro. Underneath, we declare our parameters, or variables. On the Wildlogger board, there are 3 pins that have LEDs attached, pin 13, pin 4, and pin 27. So we'll create a variable called pin LED that's an integer, and assign it the value of 13 to start. Then we can easily change the pin number through the console. We'll do this after we know how to change the blinking rate. So next we'll do the same with the blink rate. Remember that what controls the blinking rate of the LED is the delay time, or the amount of time in milliseconds between turning the pin output to high, on, or low, off. So we'll create an int variable called delay time. We need to do a few things in the setup function. First, we need to initialize the command line using command.begin and give it our baud rate of 57,600. Then we write out our title header so we know which code is on the board. We initialize our LED pin as we did in our original blink program. But instead of hard-coding the pin number to 13, we're going to set it as the variable pin LED. Then we turn it off using digital write. Finally, we add our blink command using command.add. We'll use the command keyword blink and map it to the command blink function, which we'll write later on. In the loop function, we put our command.poll function as usual. We also put our digital write and delay code to keep the LED blinking continuously. However, we're going to use our variables instead of hard-coding these values. In the digital write, we'll put pin LED for the pin number, as we did in the setup function. In the delay, we'll use the delay time variable as the amount of time in milliseconds to wait before executing the next line of code. Under the loop function, we'll create our command blink function, passing it our 2 standard arguments, argCount and args. In command blink, we're setting the delay time variable to whatever we type into the serial console after we've typed our command keyword blink. Remember that whatever is entered into the serial monitor is a string, but our delay time value or argument needs to be an integer. So we need to convert it using the command.convert function and passing it the correct string to convert. In the console, we know that our command keyword is always first and so is referenced as args0. If the second thing we type into the serial monitor is the delay time, we reference it as args1. Let's verify our code by doing a test compile. Then let's check we have our Wildlogger board selected and we're using the correct port. Then we download our code to the board. Once it's downloaded, we open the serial monitor and type blink, followed by the amount of time in milliseconds we want the delay time to be. For example, 500 milliseconds, or half a second. Keep a space between blink and 500. As we change the delay time through the serial monitor, we can see the blinking rate changing in real time. This is really powerful once we start testing our application because we can see in real time exactly how it responds. So now we've changed the blink rate, let's see how we would change both the LED pin number and the delay time. Have a go first, and then we'll share the code. So that's it for submodule 1, the command line. Congratulations, we're going to be using this for the rest of the module. Next up is submodule 2, reading our temperature and humidity sensor. Woohoo!